In this video, we will get to learn about definite integrals and their properties. A definite integral is denoted by where a is called the lower limit of the integral and b is called the upper limit of integral. Mr. Mayank Maheshwari from Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
First of all, let us understand the meaning of definite integral. Definite integral a to b fx dx means it gives the area under the curve between the limits a to b So, if the integral of fx is capital Fx, we apply the limit. First of all, a, which is called as lower limit, b is called as upper limit. We apply the upper limit first and then we apply the lower limit. So, in place of x, we first put b and then finally we put a. Now, let us come to the properties of definite integral, which are quite useful in integrating some difficult integration. Let us begin with the first property. The first property is a to b fx dx is same as a to b ft dt, which means if the limit remains the same and the function is the same, then it doesn't matter whether the function is in variable x or in variable t. Because on the left hand side we have the integral as say capital Fx, and when we apply the limit we get fb minus fa. Similarly, on the right hand side we have the integral as ft, and when we apply the limit it becomes fb minus fa, and hence they are the same. Now we come to the second property of definite integral. The second property of definite integral is a to b fx dx is equal to minus times b to a fx dx. That is, if the lower limit becomes upper limit and the upper limit becomes a lower limit, then there is a minus sign in the result. Now let us prove it. On the left hand side we have the integral as capital Fx, and on applying the limit it becomes fb minus fa. On the right hand side the integral is again capital Fx, and the lower limit is b and the upper limit is a. When we apply the limit it becomes f of a minus f of b. When this minus sign is taken within the bracket it becomes fb minus fa. So we see that if the limits are interchanged, a minus sign appears in the definite integral result. Now we come to the third property of definite integral. The third property of definite integral says that a to b fx dx can be written as a to c fx dx plus c to b fx dx, where c is a point in between a and b. We can also break this integral in more than two parts. It can be written as a to c1, c1 to c2, and so on, and finally the upper limit should be b. Now these limits are broken as per our need, as per our convenience. Now let us prove it. The left hand side is integral fx. When we apply the limits it becomes f of b minus f of a. On the right hand side, the first integral gives f of x, the limits are a to c, and the second integral again is f of x, the limits are c to b. On applying the limits, it becomes fc minus fa plus fb minus fc. We see that fc cancels out and we get f of b minus f of a, which is same as left hand side. So this is our property number third, which is quite useful in integrating the modulus function and the function in which there is a need to break the limit. Let us come to the fourth property of definite integral. The fourth property of definite integral is a to b fx dx is equal to a to b f of a plus b minus x dx. In the left hand side, let us put x is equal to a plus b minus t. Now, when x is equal to a, t becomes b. When x is equal to b, t becomes a. Also, dx is equal to minus dt. So we see the left hand side becomes b to a f of a plus b minus t into minus dt, which is minus b to a f of a plus b minus t dt. Now, when we consume this minus sign within the limit, we know that the limits are interchanged. So this becomes a to b f of a plus b minus t dt. By the first property of definite integral, we know that limit remaining the same and the function remaining the same. If we change the name of the variable only, it hardly matters. The integral is the same. So it becomes f of a plus b minus x ds. Now we come to the fifth property of definite integral. The fifth property of definite integral is somewhat similar to the fourth property with slight modification. It says that 0 to a fx dx is 0 to a f of a minus x dx. Now to prove it, let us begin with the left hand side. We put x is equal to a minus t, meaning by dx is equal to minus dt. Now let us change the limit accordingly. When x is equal to 0, t becomes a. And when x is equal to a, t is equal to 0. So our left hand side integral becomes minus a to 0 f of a minus t dt. On absorbing this minus sign, we get 0 to a f of a minus t dt. Once again, we know that if the limit remains the same and the function remains the same, then if we change the name of the variable by t to x, it hardly matters. The integral value remains the same. So it is f of a minus x dx. This is a fifth property of the definite integral, which is extremely useful while evaluating certain definite integrals. Now we come to the sixth property of the definite integral. The sixth property of definite integral states that 0 to 2a fx dx is equal to either 2 times 0 to a fx dx if f of 2a minus x is equal to f of x, or it is 0 if f of 2a minus x is equal to minus of fx. Now let us prove the property. We begin with the left hand side integral, which is equal to 0 to 2a fx dx. Let us break the limit. Let us write it as 0 to a fx dx plus a to 2a fx dx. Now we'll evaluate the second integral, say I1. If it comes exactly the similar to the first integral, it becomes 2 times. And if it comes out to be minus of the first integral, it becomes 0. Let us see what happens. Let us begin with I1, which is a to 2a fx dx. Let us put x is equal to 2a minus t. That is, dx is equal to minus dt. At x is equal to a, t becomes a. At x is equal to 2a, t becomes 0. So I1 becomes minus times a to 0 f of 2a minus t dt. We continue with I1. If we absorb the minus, then the limits interchange and the lower limit becomes 0 and the upper limit becomes a, and it becomes 0 to a f of 2a minus t dt. Now we know that if the limits remains the same and only the name of the variable is changed, the function is the same, then the integral's value remains the same. So this becomes f of 2a minus x dx. Now let us take the two different cases. Case 1, when f of 2a minus x is equal to f of x. In this case, I1 becomes 0 to a f of x dx, and hence using this value I, which is 0 to 2a fx dx, becomes 2 times 0 to a fx dx. Let us take case 2. If f of 2a minus x is equal to minus fx, in this case I1 becomes minus times 0 to a fx dx. And hence, if we put the value of I1, then our I becomes 0. So, we see that 0 to 2a fx dx is either 2 times 0 to a fx dx, that is the case if f of 2a minus x is equal to f of x, and it becomes 0 if f of 2a minus x is equal to minus fx. So it is, if it is even in the sense of f of 2a minus x, it is twice, and if it is odd in the sense of 2a minus x, it is 0. Let us come to the last property, the seventh property of the definite integral. The seventh property of definite integral states that minus a to a fx dx is equal to either 2 times 0 to a fx dx, when f of minus x is equal to f of x, that is function fx is an even function, and it becomes 0 if f of minus x is minus of fx, that is function fx is an odd function. Now let us see the proof of this property. We begin with minus a to a fx dx. Once again, we break the limit from minus a to 0 and then from 0 to a. The first integral let us call as I1 and the second integral as I2. We will be evaluating the first integral. If it comes out to be exactly similar to the second integral, it becomes twice. And if it comes out to be minus of the second integral, that is a negation of the second integral, it will cancel out and will become 0. So let us evaluate I1, which is equal to minus a to 0 f of x dx. Let us put x is equal to minus t and dx is equal to minus dt. At x is equal to minus a, t is a, and at x is equal to 0, t is also 0. So our I1 becomes minus times a to 0 f of minus t dt. Now, using the previous property of the definite integral, if the minus is consumed within the integral, then the limits interchange. It becomes 0 to a f of minus t dt. And also, by the very first property of the definite integral, the limit remaining the same, the function remaining the same, if we change the variable by x, it doesn't make any difference. So it becomes 0 to a f of minus x dx. Now once again, two cases arise. The first case, when the function is even and f of minus x is equal to fx. In this case, I1 is equal to I2, and hence I becomes 2 times 0 to a fx dx. And in the second case, when f of minus x is equal to minus of fx, that is the function is an odd function, then I1 becomes minus times I2 and hence I becomes 0. So we see that the integral minus a to a fx dx is equal to 2 times 0 to a fx dx if the function is even in nature, and it becomes 0 if the function is odd in nature.
Some properties of integrals are:
For more such videos, log on to CBSE section of jagranjosh.com.